Hello viewers, in today's class we are going to take up an important topic in three-dimensional geometry, that is the intersection of line and plane. So here we have a line and a plane. Suppose the equation of the line is x minus x1 by a, y minus y1 by b, and z minus z1 over c. So this is the Cartesian equation of the line which passes through the point x1 comma y1 comma z1, and the direction ratios of the line are a, b and c, right? And let the equation of the plane p is say ax plus by plus cz plus d equal to 0. Now here we have to find, or we have to evaluate the condition for the intersection of the line L and the plane, right? Suppose we have this plane and the line is like this. Say this is the line, and we have to find the point of intersection of this plane P and the line L, right? Suppose say P1 is the point of intersection of the line L and the plane P. Let us take here a scalar lambda, right? And if we form the equations, say x minus x1 divided by a is equal to lambda, y minus y1 divided by b is equal to lambda, and z minus z1 divided by c is equal to lambda. And if we solve these three equations for x, y and z, then we can obtain the general point or the coordinates of the intersection of the line and the plane P, right? So from here we can write x minus x1 is equal to a lambda, y minus y1 is equal to b lambda, z minus z1 is equal to c lambda, right? So x is equal to x1 plus lambda a, y is equal to y1 plus lambda b, and z is equal to z1 plus lambda c, right? So the point of intersection of the plane P and the line L has this coordinates, right? So the coordinates are x comma y comma z is equal to x1 plus lambda a, y1 plus lambda b, and z1 plus lambda c, right? Now let us take an example to explain this process, right? So find the coordinates of the point where the line through. So here we have a line which passes through 3 comma minus 4 comma minus 5 and 2 comma minus 3 comma 1 and crosses the plane 2x plus y plus z equal to 7. So here we have to first find the equation of the line which passes through these 2 points, right? So here we have 3 comma minus 4 comma minus 5 and 2 comma minus 3 comma 1. So let us take this point as a, this point as b, and let us first find the equation of the line L which is AB, right? So here we have x minus x1 divided by x2 minus x1, y minus y1, y2 minus y1, and z minus z1 divided by z2 minus z1. So here this point is x1 y1 z1, this point is x2 y2 z2. So the equation is x minus 3 divided by 2 minus 3 then we have y minus y1, so here we have minus 4 divided by minus 3 minus minus 4, and this is z minus minus 5, and then we have z2 minus z1, that is 1 minus minus 5, right? So this is x minus 3, 2 minus 3 is minus 1, so here we have y plus 4, and minus 3 and plus 4 is 1, and here we have z plus 5 divided by 1 plus 5, that is 6, right? Now this is the equation of this line AB, and we have to find the coordinates of the point where this line intersect this plane. So let us take the scalar lambda, which is used to calculate the coordinates of the general point on the line. So we have x minus 3 by minus 1 is equal to lambda, then we have y plus 4 divided by 1 is equal to lambda, then we have z plus 5 divided by 6 is equal to lambda. Now here if we solve these three equations for x, y and z, then we get x is equal to minus lambda plus 3, y is equal to lambda minus 4, and z is equal to 6 lambda minus 5, right? Now see, this point is a general point, right? This point is a general point on the line, and if this line intersect this plane, that is 2x plus y plus z is equal to 7, then this point must satisfy the equation of the plane, right? So if we substitute the value of x, y and z in the equation of the plane, then we can easily find out the value of lambda, right? Now we substitute the value, so we get 2 times for x we have minus lambda plus 3, then we have lambda minus 4, and then for z we have 6 lambda minus 5 is equal to 7. So we have minus 2 lambda plus 6, then we have lambda minus 4 plus 6 lambda minus 5 is equal to 7. So if we solve this equation which is in lambda, so we have 6 plus 6 lambda plus lambda 7, 7 minus 2, 5 lambda, and here we have 6 minus 4, 2, 2 minus 5 minus 3, and equal to 7. So we have 5 lambda is equal to 7 plus 3, that is 10. So lambda is 10 divided by 5, that is 2, right? So the value of lambda is 2. So if we substitute this value of lambda here, we can find out the point of intersection of the plane, this plane and this line. So let us substitute here. So what we will get, we'll have x is equal to minus lambda plus 3, so we have minus 2 plus 3, that is 1. Then we have y, and the value of y is equal to, for lambda we have 2, so 2 minus 4 equal to minus 2, and for z we have 6 lambda minus 5, so this is 6 times 2 minus 5, that is 12 minus 5, that is 7. So this point of intersection of the plane and the line is given by 1 comma minus 2 comma 7. So this is the required coordinate of the point of intersection of this line and this plane. Let us take one more problem. Here we have to find the distance of the point minus 1 comma minus 5 comma minus 10 from the point of intersection of the line. Vector r is equal to 2i cap minus j cap plus 2k cap plus lambda times 3i cap plus 4j cap plus 2k cap, and the plane vector r dot I cap minus j cap plus k cap is equal to 5. So here we have the plane pi and the line L, and first we'll find the point of intersection of this line L and the plane pi, and then we'll find the distance of the point P1 from this point S, right? So this will be the distance between the point S and P1. Let us first convert the equation of the plane pi and the line L into Cartesian form. So this equation of the plane can be written as x minus y plus z equal to 5, and the equation of this line, which is given in the vector form, can be written in the Cartesian form as x minus 2 divided by 3, then we have y plus 1 divided by 4, and z minus 2 divided by 2, right? So in order to find the coordinates of the general point on the line L, we can take the scalar lambda. So therefore here we can write x minus 2 by 3 is equal to lambda, y plus 1 divided by 4 is equal to lambda, z minus 2 divided by 2 is equal to lambda. And let us solve these three equations for x, y and z. So therefore x is equal to 3 lambda plus 2, y is 4 lambda minus 1, and z is equal to 2 lambda plus 2, right? Now the coordinates of the point P1 are given by these three coordinates, that is 3 lambda plus 2, 4 lambda minus 1, and 2 lambda plus 2, right? Now see the point P1, it lies on the plane, so this point P1, it will satisfy the equation of the plane, which is equation number 1. So if we substitute here for x 3 lambda plus 2, for y 4 lambda minus 1, and z equal to 2 lambda plus 2, then we get 3 lambda plus 2 minus 4 lambda minus 1 plus 2 lambda plus 2 is equal to 5, right? Now this equation in lambda can be solved, and this is a linear equation in lambda. This is 2 lambda plus 2 is equal to 5. So this is 3 plus 2 5 minus 4 lambda, that is lambda, and 2 plus 2 4 plus 1 5 is equal to 5, and from this equation we see that lambda is 5 minus 5, that is equal to 0. So the value of lambda is 0. Now if we substitute lambda equal to 0 here, then we get the coordinates of the point P1. So this is 0 plus 2, 3 times 0 plus 2, 4 times 0 minus 1, and 2 times 0 plus 2, and the coordinates of the point P1 are 2, minus 1 and 2, right? Now we have to find the distance of this point, that is point S, from this point P1. So here we'll apply the distance formula. So the distance formula is x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square, right? So we can take this point as x2 y2 z2, and this point as x1 y1 z1. So here the point P1 is 2 minus 1 2. So now substituting the values of x1 y1 z1, x2 y2 z2 in this formula, we'll get x2 minus x1, that is minus 1 minus 2 square plus minus 5 and minus 1 square plus we'll have minus 10 and minus 2 square, right? So SP1 can be now written as so this is minus 3 square, and here we'll have minus 5 and plus 1, that is minus 4 square, and here we have minus 10 and minus 2, that is minus 12 square, right? So SP1 is now equal to square root of 9 minus 3 square is 9, then minus 4 square is 16, and minus 12 square is 144, right? So if we add all these three numbers, we get 169, that is square root of 169 is 13. So the distance between the point S and P1 is 13 units, right?